Hey, Radzien here. In this video, we will create an app for guitarists to visualize scales on the fretboard using React, TypeScript, and Next.js. You can check out the final result at pentafret.com and explore the codebase on GitHub. To kick things off, we will use the RadzionKit starter, which provides a comprehensive set of components and utilities designed to streamline React app development and boost productivity. I have always had a guitar and often come up with riffs and melodies, but I struggled to develop them further because I did not know any music theory. To change that, I picked up a book called Fretboard Theory to learn the basics. One of the first topics it covers is the layout of notes on the fretboard along with scales and pentatonics. This inspired me to build an app where you can visualize all of this on a fretboard, making it easy to explore different patterns in one convenient place. Our app will feature two main views. The first will be a homepage that displays all the notes on the fretboard, and the second will be a scale page where you can select a root note and a scale. On the scale page, you will also have the option to toggle between viewing the full scale or its pentatonic version. While this app could be built as a React single-page application, that approach would negatively impact SEO. Instead, it is better to create a proper pages for each pattern. We have two options: server-side rendering or generating static pages. Since the app will only require around 200 pages, generating static pages is a great choice. It is cost-effective because we do not need to pay for a server, and the pages can be served through a SDN for free or minimal cost. Let's start by implementing the homepage, which we will call Notes page. We will wrap the homepage as a page container component which uses centered content and vertical padding utilities from RadzionKit. These utilities ensure the content has a responsive horizontal padding, a maximum width of 1600 pixels and vertical padding of 80 pixels. Next, we need to create a proper title to improve our chances of ranking on Google. We will display a main heading for the main title and include meta text to set the page title and description. To generate that copy, I use AI. However, for AI to truly understand the product, it needs context. To address this, I always maintain a file called context.md that contains all the raw information about the project. Whenever I need to add the AI something, I start by sharing this context first. While it takes time to write and maintain initially, it saves a lot of effort in the long run. You do not have to explain the project repeatedly, and with better context, the AI delivers more accurate and relevant results. The content of our notes page is straightforward: a fretboard displaying all the notes. We use a fretboard component as the container and pass the notes as the children. We use the neck component as the container for our fretboard. It is a flexbox row element with a fixed height and a relative position. Other static parameters like the neck height are stored in a single source of truth within a configuration file. The first child of the neck component is the open notes component, which acts as a placeholder for the open notes. It has a fixed width equal to the size of a node plus the offset. Next is the nut component, which also has a fixed width but includes a background color to visually highlight the beginning of the fretboard. The frets component occupies the remaining space, features a background color to contrast with the page background, and uses a relative position to enable absolute positioning of its child elements. Next, we iterate over the visible frets and render a fret component for each one. Variables like the number of visible frets and string count are stored in a separate configuration file. This file also includes other essential parameters such as the total number of frets, the tuning of the strings, and the thickness of each string. To represent a fret, we simply render a line with a width of 1 pixel. To position an element by its center on the horizontal axis, we use a utility component from RadzionKit designed for positioning elements precisely. To calculate the left position, we use a getFretPosition utility function. This function returns the start and end position of a fret based on its index and the total number of frets. To make the fretboard look more realistic, we ensure the frets get progressively closer together as they move up the neck. To enhance realism, we also display fret markers. We use a positioning component from RadzionKit to position the markers on the fretboard. The getFretPosition utility helps us determine the start and end positions of each fret. Since the fret position is represented as an interval, we can easily calculate the center of that interval for accurate placement. Depending on a marker's type, we render either a single dot or double dots. To handle this, we use a conditional rendering component from RadzionKit, which allows us to render different components based on the marker's type. This approach serves as an excellent alternative to traditional switch statements. To decide which fret should display markers, we use the getFretMarkers utility function. This function returns an array of objects, each containing the fret index and the type of marker to render. Finally, we render the getter strings. For vertical positioning, we use another RadzionKit component that centers elements horizontally. To enhance realism, we use a repeating linear gradient to create a pattern that simulates the texture of real getter strings. With the fretboard component complete, we return to the nodes page content component to display the actual nodes. Here we iterate over each string and visible fret. Starting with the node of the open string, we add the fret index to calculate the node's position on the chromatic scale. We also determine whether the node is natural or sharp or flat. By setting a property to secondary, we make sharp or flat nodes less visually prominent. We represent each node with a number. A is 0, A sharp is 1, and so on. To generate names for the nodes, we use a minor scale pattern and iterate over it. For each step in the pattern, if the step equals 2, it indicates a sharp node between the two natural nodes, so we include it in the array. To determine if a node is natural, we check if its name has a single character. Our node component supports three kinds: regular, secondary, and primary. The primary kind is used to highlight the root node of the scale. To position a node, we pad the string index and fret index. If the fret is null, it indicates an open string. As with other fretboard elements, we rely heavily on constants from the config files to calculate the node position. Another positioning component from RadzionKit helps us place the node precisely by its center. With all the nodes displayed on the fretboard, we can now move on to the scale page. This page uses a dynamic route with three parts: the scale type, the root node, and the scale name. The scale type can be either scale or pentatonic. The root node is one of the 12 nodes, and the scale name corresponds to one of the predefined scales. We represent a scale as an array of steps, where each step indicates the number of semitones between two nodes. Most scales have 7 steps, while pentatonic scales have 5 steps. To manage the selected configuration, we use a scale state type. This state is stored in array context. Using a utility from RadzionKit, we create both a provider and a hook for accessing that state easily. When the user changes the scale type, root node, or scale, we need to redirect them to the new URL. For this, we use a custom hook that retrieves the current scale state and the router instance and returns a callback that updates the URL based on the new scale state. To construct the URL, we use a makeScalePath utility function. To make the scale page URL more readable, we convert the numeric node into a UI-friendly format. The sharp symbol is replaced with sharp, and the node is converted to lowercase. To reverse this process and convert the URI node back to a numeric node, we use another utility function. Since each scale has its own static page, we need to generate them. Using Next.js functions, we generate all possible paths by combining scale types, root nodes, and scales. The data is extracted from the URL and provided as props to the page. The scale page component receives the scale state as props and passes it to the scale provider. This allows child components to easily access the scale state. At the top of the page, we display control that let the user select the scale they want to view. These controls include the root node, scale, and scale type. They are arranged in a flexbox row for clean layout. To display the root node and scale selectors, we use the expandable selector component from RadzionKit. You can learn more about its implementation by checking the corresponding YouTube video in the description. To toggle between the scale and pentatonic views, we use the grouped radio input component from RadzionKit. Next, we display the title, which follows the same principle as the homepage title, but this time it is generated dynamically based on the selected scale. Based on the selected scale type, we retrieve the appropriate pattern from either the scale patterns or pentatonic patterns records. We then use a getScaleNodes utility function to determine the nodes of the scale. Next, we iterate over the strings and frets, rendering a node only if it belongs to the scale. If the node is a root node, we highlight it. When displaying the pentatonic scale, we also render the 5 pentatonic patterns. It is common practice to learn them individually. We create a separate section on the page for this, complete with the H2 title. Within the section, we iterate over the 5 patterns, rendering only 2 nodes per string and shifting the pattern by 1 node with each iteration. This allows us to display all 5 patterns on individual fretboards. With this app, guitarists can easily visualize scales, explore patterns, and better understand the fretboard. By combining React, TypeScript, and Next.js, we created a dynamic and SEO-friendly tool that serves as both an educational resource and a practice companion. Happy playing!